Okay, so we are continuing our discussion on scalars and vectors. Scalars and vectors. And as promised, the next topic is the geometrical representation of the vectors. Okay, the geometrical representation of a vector. So when I say that I have a vector, how should you think about it? What kind of picture should come to your mind first? Geometrical representation of vectors. Okay, so that is the geometrical representation. Okay, how should you think about a vector? And the way in which we think about it is this is the kind of thing that you should think about: a tail and a head. This arrowhead is what it is. This is called a vector. Okay, this is the arrowhead and this is the tail of the vector. Okay, now what it is trying to tell us. What was a vector? A vector was any quantity which was described by a number, and that number I called the magnitude. Yes, a magnitude. A magnitude told me how much is that vector. Okay, this information of how much, and a direction. Yes, and that direction tells me in which way. In which way. Okay, so this representation, is it telling me both of the things? See, this arrowhead direction tells me the direction of the vector. So that is very intuitively clear to us. But what about this magnitude? This magnitude tells me how much of that vector is there, and that how much answer is given by the length of the vector. So more the longer the vector, more will be its magnitude. So let's say I have a velocity vector like this and a velocity vector like this. Then the length of this vector, a vector, and this is how I symbolically write it. Huh? Symbolic representation is something like this. Symbolic representation is something like this. If I say A is a vector, then how should I write it? I should write A and I should write this arrow on top of it. And maybe something like this, A bar also works. In some of the texts, you write this bold A. So this is bold A. Okay, all these things are telling me that A is a vector. Okay, so let me say that I have a vector like this. Okay, a vector A vector, and you have a vector B vector. Then just by looking at this, what did I say? That magnitude of a vector, equal to the length of the vector, no? The length of vector. If this is so, then right away you should say that magnitude of A is greater than magnitude of B. Yes or no? Should be magnitude of A vector is greater than magnitude of B vector. Okay. So this representation that we have, this representation of this arrow with the tail, what will be the significance of this tail? I will tell that as well. Okay. But for now, the length and the direction both are defined by this representation. So whenever I am talking about a vector, this is the thing that should come to your mind, a vector with a tail. Okay. So this is the geometrical representation. I hope the symbolic representation is clear to you as well. Okay. So the next topic that you should come is this, the types of the vectors. So when we talk about vectors, there are many types of vectors that we have to deal with, and there are certain important types of vectors, okay, which I am going to introduce now. They will be important to us and they will be useful to us in the long term. So the first vector that I want to discuss is a zero vector. A zero vector, it's also called a null vector. Okay. Even in numbers, the most important number is actually zero. It it describes everything, the addition, subtraction, all of those things, and much more things. Okay. So here as well, you can't add a vector plus a zero. This kind of addition is wrong because here 0, if I don't write a vector sign on top of it, then it's a zero scalar. Okay. And in general, you should remember, in general, vectors do not add with scalars. Vectors only add with vectors. Okay. So what did 0 represent in our scalars? It represented nothing. Okay. If I say I have 3 apples, then how many mangoes do I have? I have 0 mangoes. Okay. 0 mangoes. So the absence of that thing is given by that number 0. Okay. So if I'm talking about vectors, then what does the 0 vector represent? So the 0 vector is symbolically given like this. Symbolically given like this. 0 vector. Okay. What will be the length of 0 vector? The length of 0 vector is 0. So the length of 0 vector represents what? The magnitude of the 0 vector, and that is 0. What will be the direction of its 0 vector? There is no direction. If the length is 0, then this vector is shrinked to a certain point. And what will be the direction of a point? There is no direction. Direction is undefined. Okay. So what does a 0 vector look like? It looks like a point, basically. Okay. This is a point. Is 0 vector. Okay. So in addition and subtraction even, we will use this 0 vector a lot. So I have introduced this. So what are the two main things about a 0 vector? The length of a 0 vector is 0 and its direction is undefined. What about the next one? The next one is called a unit vector. Okay. So a unit vector. A unit vector, by its name itself, the length of the unit vector is unity. Length of unit vector is unity. And by unity, what do I mean? That the length of unit vector is 1. A unit vector is symbolically written like this. Symbolically, it is written like this. If A is a vector, then its unit vector is given like this. A cap. Okay. And what will be the magnitude of A cap? Magnitude of A cap. So I said A with a cap. With a cap or hat. Sometimes people say hat. Okay. So there's no arrow, it's cap. Okay. So magnitude of a cap is equal to 1. Okay. What about the direction? So it's a vector with a length, unit length. So its length is equal to 1. But it has still a direction. Okay. So it still has a direction. It still has a direction. Okay. So what is the difference between 0 vector and a unit vector? The length are there the length was 0. Here the length is 1. There it did not have any kind of direction. Here there is a direction. So why am I introducing this unit vector? The use of a 0 vector is understood to us because the use of 0 is a lot, even in algebra, basic algebra. What about unit vector? A unit vector's job, the job is basically use unit vector as a pointer, as a pointer. Okay. So even in games, you might have seen that when you are moving in one direction, there's a pointer in front of you. That is telling me in which direction you are moving. So the whole job of a unit vector is actually just a pointer. It gives direction. So its job is to tell me direction. Because what are the two things that we can extract from a vector? The two things are its length and its direction. As we already know, the length of a unit vector is 1. So the only thing that we can extract is direction. Okay. So its job is to specify direction. Okay. And you will understand the use of a unit vector in the coming lectures. For now, this is the main two things about unit vectors. The length of the unit vector is 1, and it has some kind of direction, and that direction is used as a pointer. Okay. What about the third thing? The third vector which I want to talk about is called the negative of a vector. Negative of a vector. So you already know if you have a number line, in that number line we have certain numbers. Okay. So you have 0 here, and then there's 1, there's 2, and there's 3, and so on. And there's -1, -2, -3, and so on. So if you have a number here, you have its counterpart here. This is the position at which it will sit. Okay. What about the negative of a vector? How will it look like? Okay. So the negative of vector is something like this. So you have a vector. So I'm going to geometrically tell you how it is. We will define it much more when I will talk about how to find the magnitude of a vector and how to write the unit vector formally. For now, if a vector is something like this, if I have a vector like this is my a vector, then minus of a vector is, so the length will be same, but the direction will be completely different. It will be opposite direction. That negative sign basically tells me in opposite direction. This is minus for a vector. Okay. So the direction is exactly opposite to a vector. Okay. But what about the magnitudes? Will the length change? It will not change. So the magnitude of a vector is equal to magnitude of minus a vector. Okay. So when you take the negative of a vector, if you take the minus sign in front of it, the only thing that you have to do is change its direction. Its magnitude will not differ. Okay. So this was the negative of a vector. All these terminologies, all these vectors will be helpful to us. What about the fourth one then? The fourth one is called equal vectors. So actually there are many kinds of vectors that we can talk about, but I have specifically picked these four for us for now. Okay. So what are equal vectors? If two numbers are equal, if A and B are two numbers, are two numbers, and say they are equal. So what does it mean? That number are equal. So this, if I say 25 by 4 is equal to 5 by 2, then they are equal, right? The magnitudes are equal. So basically, if two numbers are equal, their magnitudes are equal. Not the magnitudes, but the number themselves are equal. But what about vectors? If two vectors are equal, if A vector and B vector are called equal vectors, then what happens? Then they should have same direction as well as same magnitude. So the length of the vector should be exactly same. If this is A vector, then the length of the B vector should be exactly same as well, but in the same direction as well. So you can't pick opposite direction or anything like that. You can't pick two vectors whose length are equal but not their directions. Okay, so both of the things should be same. So magnitude of A equals to the magnitude of B, and direction of A equal to direction of B. I can even say कि A cap equal to B cap, because the whole point of unit vectors was to specify direction. So I can put a pointer in this direction, a little pointer that will tell me the direction of A vector. This pointer will tell me the direction of B vector, and those caps are same. Okay, good. So I think the idea is clear to you that for two vectors to be equal, you can't say just कि their magnitudes are same, or you can't just say that direction are same. So let me give you an example, and the example is something like this. Say you have two vectors like this. This is A vector, this is B vector, and given to you that magnitude of A equal to magnitude of B. Then are these vector equal vector? Then is A vector equal to B vector? What do you think? Obviously no, right? Because what? The directions are totally different. A cap is not equal to B cap. Yes, if you take the pointers are not in the same direction. You can check. See, it has a pointer in this direction, a little pointer like this, and it has a pointer in this direction. Okay. Remember, the direction, the length of a unit vector should be equal to 1. So obviously it's going to be a little smaller than the original vector. Okay. So I think the idea is clear to you. Acha, if two vectors are something like this and they have the same direction, A cap equal to B cap, but their magnitudes are not same, here still A vector is not equal to B vector. Okay. So I think you have understood the idea of how two vectors will be equal. They will be equal only if their magnitudes are same and the directions are same as well. Okay. Then let me talk about the last thing for today. It's called the properties of vectors. Okay. So there are certain properties that we can use, that we can exploit when we are doing vector algebra, and which I will introduce in the later lectures. So the first thing that you should always remember, if you have a vector here, then you can always move it freely. This can be moved freely. But one thing that you should understand, never rotate the vector or never change the direction of the vector, never change the magnitude of the vector. In doing so, do not change its direction or its magnitude. Okay? Direction or its magnitude. Okay? Magnitude. So let's say you have a vector like this. This is my coordinate system. This is my coordinate system. You have y-axis, this is x-axis. You have a vector like this, a vector. And you can take this vector and place it here. You can do so, but don't change the magnitude or the direction. Okay? This is a vector, then this is also a vector. You can place it here, you can keep it. Okay? You can move them freely. This can be freely moved. I did not write moved. So this is one of the properties of a vector. You can move it freely, but in doing so, do not change its magnitude or direction. Okay? So I think the first property is clear. When we will use this property? When I will talk about how to add two vectors graphically, there you will understand how we can use this property. What about the angle between two vectors? Angle between two vectors. What about this one? So if let's say we have two vectors like this, I have a vector b vector like this, and I have a vector a vector like this, then what is the thing? You can always move them freely. Move freely. And the way in which I will put the vectors is I will put the tail on tail of A on the tail of B. Okay. So put this vector, place its tail here. So they are put in the tail to tail position. So let me do this. Okay. Hopefully I do justice to it. Yes. I think it approximately looks the same thing. This is B vector, this is A vector. And they are put in the, they are put in a tail to tail position. Okay. And only in this position will you measure the angle between two vectors. Do not put the tail on the head of a vector B. Do not put the tail of B on the head of A. Put the tail of A on the head of B. Then there are two angles that you can consider here. There's an angle here like this. This is called phi. And let's say this angle theta. Then which angle should we consider? Which angle to consider? Okay. And the answer to this question is that always pick the smaller of the two angles. Of the two angles. Okay. So let's say one of the angles is maybe 100 degrees, the other is 260 degrees, then you should always pick the 100 degrees. That is the angle between the two vectors. Okay. When they are put in a tail to tail position only, please understand. Do not put them in a tail to head or never put them in a tail to head position and then find the thing. Only in the tail to tail. Smaller of the two angles. Okay. So let me give you an example and then it will be clear to you. So the example is something like this. You have a vector like this, A vector. You have a B vector like this. Okay. And the angle here is maybe 50 degree. And this angle here is, it should be 310 degrees. Okay. Then what is the angle between, so let this, an angle between A vector and B vector equal to how much? It should be 50 degrees. Okay, always pick the smaller angle. And do you see? They are put in the tail to tail position. Okay, this is very important. They should be put in the tail to tail position and you should always pick the smaller angle. That is the angle between the two vectors. So these two things are important. Okay. Then the last thing I want to discuss, that angle between, so one thing you should consider, if you have two parallel lines, okay, then angle between parallel lines is either 0 or 180 degree. Yes, either 0 degree or 180 degree. Okay, then let me draw two vectors. A vector like this, and even if I take anti-parallel things, then even in anti-parallel you wouldn't understand the difference between them. Yes, but what about here? If I take these two vectors, then A vector and B vector are called to be parallel vectors. These are parallel vectors. Okay. If I put the tail of B vector on the tail of A vector, then what will be the direction? What will be the angle? The angle between them would be equal to 0, right? Angle between A vector and B vector equal to 0 degree, right? For parallel vectors. But what about this thing now? Let's say I have a vector like this, A vector, and I have a vector like this, B vector. Okay. Now, if I want to move them freely, and if I want to find the angle, then put tail to tail position. So I can put this thing, I can take this B vector, put the tail here. Yes. And if I put the tail there, then what will I get? This is B vector. This is A vector. What is the angle between them? If I take this angle or I take this angle, it does not matter. The angle is 180 degree. Yes, it's equal in both of the sides. Then angle between these two vectors, angle between A vector and B vector is actually 180 degrees. So it's different. See, this case, this is case 1, This is totally different from case 2 because the vectors are totally different. You know, in one of the case 1, the vector b is pointing in this direction, but now here it is pointing in this direction. Okay, these kinds of vectors who have angle between them as 180 degree, this is called anti-parallel vectors. Okay, if one is pointing in this direction, then the other will point in the exact opposite direction. Okay, so this is the basic amount of terminology that you should know before going forward into the algebra of the vectors. Okay, so from next lecture onwards, I will talk about how to add two vectors. With all the information that we have gained up till now, this will be useful to us in the addition of the vectors, the subtraction of the vectors, and the multiplication and so forth. Okay, so hopefully let's meet in the next lecture. See you soon.